So I guess we're just going to need to scan it now.
Wow. I guess that's the solution. Just a second here. Let's see.
Okay. Okay.
Get these where I can download them.
Okay, cool.
Scanning obviously works.
Uh-huh.
I think your phone works also. You just have to figure out
like how to...
My email.
Like,
you got my email off by a character.
Yeah, oh, yeah.
That's the only solution I can think of.
Yeah.
It has to be that. Because there's no reason you shouldn't be able to send me an email.
Exactly.
Do these start from... Is this the first page?
Yeah. Actually, I think I left it on the scanner. Do you mind if I go get it real quick?
No, that's fine. Go ahead.
Okay, sorry about that. Just a sec.
I gotta figure out how to rotate. Let's see. View, rotate, view, counterclockwise. There we go.
Okay, got it. Okay.
So do we want to start this session on a proof?
Sure. Yeah, we can do that. Okay. So given...
Prove that EFGH is a... What do you think it is?
Rhombus. Or like a... Yeah, rhombus.
What's it look like? What's it look like?
Looks like a square.
That it is a square.
Okay.
So we have to prove that it's a square.
Okay.
And the way we're going to do that is to prove that we have 4 equal sides.
Okay.
And that each of these is a right angle.
Okay.
Okay.
Cool. Okay.
And that has to be a square. In other words, if we had merely 4 equal sides, we'd have a rhombus. But if we have 4 equal sides and a right angle at each one, then we have a square.
Okay. Yeah, that makes sense.
The goal is if I can... Well, you tell me. What should I be trying to do here? First of all, how am I going to prove that those sides are equal? What's a mid goal? In other words, somewhere along in this middle range of the statements, I have to say what?
Find out like which angles are congruent to each other.
Which triangles are congruent?
Which triangles?
In other words, if I can prove that triangle is congruent to that triangle, which is congruent to that triangle, which is congruent to that triangle, now each of these sides has to be equal because CPCTC.
Okay.
Because they would be the corresponding part of congruent triangles.
Okay.
Okay. So, I don't want to spend forever on this because I'm sure that, in other words, I'm going to go through these statements and reasons. Statement 1 is always the given. And
yeah, for sure.
1 is always the given. So basically, whatever you see there, you repeat in that line, and the reason is given. Okay?
Okay.
My goal is somewhere by statement 4 or 5 to prove that this triangle is congruent to that triangle.
Okay.
So what could statement 2 maybe be?
So we know that so like with the given, we know that PQRS is a square. We could say...
What does that mean about PQ, QR, SR, and PS?
They're all congruent.
They're all equal. Well, yes, they're all congruent.
Okay.
Reason, definition of a square.
Okay.
Okay. Now what else can you say? Based on the fact that E, F, G, and H are midpoints of each of those sides, what does that tell you about PF and FQ?
Well, first, so like For number 2, it'd be the definition of a triangle, correct?
No?
Or of a square, my bad.
Yeah, number 2 is PQ equals QR equals SR equals PS. And
Okay.
the reason that's true is definition of a square.
Okay. Okay, yeah, I got that.
Okay?
Okay,
Statement 3.
Mm-hmm.
Now we want to start looking at these individual triangles. That triangle, this triangle, this triangle, and this triangle. If I can prove they're all congruent,
That's a square.
well, no, then I know that EF is equal to FG, which is equal to GH, which is equal to EH.
Okay.
Once I prove all 4 triangles are congruent, then that means these sides of that middle figure are equal.
Okay, that makes sense.
Okay. Well, in order to prove these are congruent, what do I need to know about PF and FQ?
PF and then FQ. Well, F would be the midpoint, wouldn't it, of
That's the
PQ?
given.
Oh, yeah.
That's in the given, is that F, E, H, and G are each the midpoint of those lines. So
Okay.
what can you say based on that?
Well, based on that, we could say that we know they're all midpoint, and it doesn't bisect anything.
That's what midpoint means. Yes, that's exactly what midpoint means, is that it bisects that line.
Oh, okay.
Okay. So what does it mean about PF, FQ, QG, GR, RH, H, whatever that letter is, whatever that letter is, E, and EP? What is true about all of those?
They're all equal to each other.
Exactly.
Okay.
The reason for number 3 is definition of midpoint.
Okay, cool.
Midpoint bisects the 2 sides. So that's why PF is equal to FQ. And I also know that QG is equal to GR for the same reason. And I know that RH is equal to HS for the same reason. So I might have to make that statement that each of those 8 segments are equal, congruent.
Okay, that makes sense.
And the reason is definition of midpoint.
Okay.
Okay. Now that I know that PE is equal to PF, and each of these sides of each of these triangles are equal, what kind of triangles are they?
Isosceles.
Correct. What's this angle right there?
60.
No.
Well, so isosceles has 2 equal sides, right?
2 equal angles. Those are equal. What are they each?
They're each 9. No, they're not 90. 45. They're 45s.
Yes. What's the sum of the acute angles in a right triangle?
90 degrees.
Okay, and if they're both the same, what are they each?
45.
Okay, so now we know that's 45, 45, 45, 45, all the way around. Okay.
Okay.
And now we know, because if that's 40, well, actually, we know those are 90 degree angles. We know E, the sides are equal, so we have all the information we need to prove congruency.
Oh, yeah, for sure.
Side, angle, side.
SAS. Okay.
So now we know they're all congruent, all 4 triangles, which means that EF is equal to FG, it's equal to GH, is equal to EH.
Okay.
Now the only last thing we have to prove is that these are 90 degree angles.
Okay, yeah, for sure.
Well, if that's 45 and that's 45, that's 90.
That has to be 90, yeah.
If that's 45 and that's 45,
then that has to be 90.
And the definition is that, I don't even know what you call 3 angles that make up a linear pair. You know what I'm saying?
Yeah, like
In other
3.
words, I wish they didn't have the word linear pair.
Yeah, me
In other
neither.
words, this is called linear pair. We know that linear pair angles are supplementary, but
Mhm.
if we have three angles that make up a line, like this,
Mhm.
and we know this is the same as this, and we know that's 90, we know all three angles have to add to 180.
Uh-huh.
So x,
Yeah.
in other words, we know that this is 45, and we know that's 45. Since they all have to add to 180, that one's 90.
Yeah, exactly.
That same reasoning is for every one of these angles. In other
Okay.
words, if we know each of these are 45, then each of these has to be 90.
That makes sense. Okay.
Now we know that is a square. Why?
Uh-huh.
Because it's got four equal sides and
Better than
four 90-degree
yeah.
angles.
Yeah. Awesome.
Okay?
Okay.
Is that
Okay.
all that's on this page?
Yep. Yep, that's it for
Close
that
that
page.
one out, and I think the order I think that was this one here. No,
Sure.
I went in the wrong order. Here, let me open the second one.
That's okay.
Oh no, that was the one we were looking at.
So we could just do, yeah, I guess it's only, yeah, 2 pages.
Oh, there's
So
two
we could,
pages that are the same.
oh, that makes sense. Oops.
Okay, that's fine. That means there's only three pages of material. Okay. Now,
Yeah.
let's see. I got to rotate this
Oh, whoops. My bad.
counterclockwise twice.
Uh-huh.
Okay.
There we go. Okay.
Geometric delight. Excuse me.
Yeah, it's all good.
Excuse me.
Bless you.
Allergic to the geometric delight. Fortified with algebra.
I'm just allergic to math, period.
Okay, solve each problem for the requested value and provide the theorem you use to do so. Okay, so how do I solve the first
For the first one, would you do 2x minus 7 plus 62 plus 36 equals 180? Or no?
one? No, those are not the three angles that make up that triangle.
No. Oh, I think I know what to do. So you'd add up 62 plus 36, and then 2x minus 7 is equal to 98.
Very good. In other words, the exterior angle is equal to the sum of the two angles that it's not next to.
Okay.
Okay, and the reasoning is that, see this angle right here?
Uh-huh.
That's supplementary to 2x minus 7, correct?
Uh-huh.
It's also supplementary to these two.
Okay.
Since it's supplementary to both, then this one must be equal to the sum of those two.
Okay.
That's
That makes sense.
one way to remember it. So let's go ahead and do the algebra. We might as well get an answer on these.
Yeah, so x would be 52.5.
They couldn't make it simple, could they?
Nah, they really couldn't.
Okay.
And
Second.
then what theorem would that be?
The exterior angle theorem.
Okay, that makes sense.
And I think you want to just call it that. You don't want to call it by a number because
No.
the number in your book's not the same as the number in my book or maybe somebody else's book.
Exactly,
So
yeah.
you can't go on Google and say, what's theorem 8.1? It won't know what you're talking about. But if
Okay.
you said, what's the exterior angle theorem, then it would know.
Uh-huh.
Okay?
Okay. Yeah.
So number 2, what are we looking at? What kind of figure?
We're looking at a parallelogram.
Okay.
What? Yeah, so it'd be a rhombus.
What's true? No, it's not a rhombus.
Or no, just a
What's the
parallelogram.
first most important thing about a rhombus?
That two sides are congruent.
No,
All four. My bad.
That's
Are
the
congruent
only
to each other.
difference between a parallelogram and a rhombus. In other words,
Okay.
if I make this side the same as that, then it's a rhombus.
Okay.
Okay, a rhombus is a parallelogram, incidentally. But
Yeah.
not all parallelograms are rhombuses. For it to be a
Mm-hmm.
rhombus, it's got to have 4 equal sides.
Mm-hmm.
Okay? However,
Okay.
parallelograms do have a property. What's true about parallelograms?
Parallelograms have two opposite sides that are congruent to each other.
Okay, we don't see any side distances here. Everything they're
Well, they
asking
all.
about, hold on. Everything
Yeah.
they're asking about is what? Is it an
Like, are they?
is it an angle or is it a side length?
They're sides.
No.
Or no?
5x
Oh, they're angles. I guess.
that
Yeah.
angle.
That's an angle right there.
7x
Yeah.
minus 13 is that angle.
Uh huh.
Y is that angle.
Okay.
We have no side lengths. So
No.
generally, if you have no side lengths, they're not asking you about sides.
Okay.
They're asking you strictly about angles. Well, what do
Okay.
we know about angles for parallelograms?
That they add up to 360.
Okay, what else do we know? That
Uh,
won't help, incidentally, here.
that won't
Because
help.
first of all, well, they haven't told us what this angle is.
No.
And if I added that plus that plus that plus that unknown angle and set it equal to 360, I can't solve it.
No, you
Two
can't.
variables and one equation.
Yeah.
So what else do we
Okay.
know about parallelograms?
That the opposite sides are congruent to each other.
So not sides. We're not talking
Or
sides.
angles, gosh.
Okay.
Yeah, I meant angles. My bad.
Opposite angles are congruent.
Uh-huh.
So what can I write?
So we could say 5x plus 7 is equal to 7x minus 13.
Okay, solve that.
Let me write it down. Minus 13. So we could subtract 5 from both sides.
Hold on.
So we could get
Subtract 5x from both sides.
x. Yeah, 5x. My bad.
Okay.
Is equal to that would make it 7 is equal to 2x minus 13. You would add 13. So 2x would be equal to 20. So x would be to 10.
Okay, and that allows us. We've just solved for that angle and that angle.
Uh-huh.
Okay.
Exactly.
Now
Yeah.
this angle is y. What is this angle up here?
Y as well.
Okay. Does that help? So how do I solve? How do I figure out what y is? What else is
When
true?
you
What else is true about parallelograms besides opposite angles being equal? What are adjacent angles?
adjacent angles are equal to 90 degrees, right?
Look at those two angles. If you add those two angles together, do you get 90?
No.
This angle alone is greater
That's
than
the obtuse angle. Yeah.
So what probably is it if it's not 90?
180.
Okay.
Yeah.
80, the magic number.
Mm-hmm.
And that's true with quadrilaterals as well as triangles. Because
Okay.
with parallelograms, its adjacent angles are supplementary.
Uh-huh.
So I can add this one to that one, or this one to that one. Either
Okay.
way, they're going to come out to 180, and I know what x is. X is 10, so let's add this one to that one. So 5 times 10 plus 7 is this angle here,
Is equal to 180.
plus y equals 180.
Okay.
Adjacent angles. This one is
Okay.
adjacent to that one. This one is adjacent to that one. And this one is adjacent to that one.
Okay.
Any
That makes
two
sense.
adjacent angles are supplementary.
Okay. That makes
Now
sense.
you can solve for y. What's y equal?
180 minus 57. That'd be 3. So that'd be y would equal 123.
Uh-huh.
Cool.
Now, what's the theorem?
That would be the definition, or no, that's not it.
Well, if you only could give one thing, yes, that's the definition of parallelogram.
Of a parallelogram, yeah.
More specific,
We could,
there's two theorems that are in play.
we
What
could say,
theorem you told me already. What was the first one that allowed us to solve for x?
the exterior angles theorem.
No, that was over here on this problem.
Oh, I thought you meant
Not
that one.
the exterior angle.
Yeah.
But for this problem, you told me that this was equal to that.
So it'd be the alternate interior angles
Opposite angles.
or opposite angles.
Of
Okay.
parallelograms are equal.
Okay.
So that's theorem 1 that's at play.
So parallelograms are equal.
Theorem 2, how did we solve for y?
For 2 we set set it equal to 180.
What's the theorem say?
Uh,
What are those angles called?
Opposite angles.
No. Opposite is that one and that one, or that one and that one.
So supplementary angles.
Adjacent.
Oh, that's right. My bad.
Adjacent angles are supplementary in a parallelogram. And that's all you need to write. In other words,
Okay.
for theorem, you got two things. Opposite angles of parallelograms are congruent, and adjacent angles of parallelograms are supplementary.
Okay.
And that's the only two theorems we used to solve that problem.
That makes sense. Okay.
Okay, now we have trapezoids. Now, this does not look like
Irregular.
Well, it doesn't look like an isosceles trapezoid.
No.
In other words, that angle is not the same as that angle. So
Okay.
it's not isosceles. In other words, if that side was the same length as this side, then that angle would be the same as that angle. In other words, if I could call this an isosceles triangle or trapezoid, then I could say 4x plus 3 equals y. But it's not an isosceles trapezoid.
Yeah, because those two sides aren't congruent to each other. They're equal.
A similar theorem applies in trapezoids that applies to parallelograms. Which one is it? If you had to guess, if you had to guess the relationships between these four angles, what would you guess?
I would guess that they would all have to add up to 360. Well.
Okay, that's true. They add up to 360, but notice what kind of an equation that gives us.
Yeah.
It gives us one equation and two variables.
Which you can't solve.
That's not going to do us any good, right?
Yeah.
What else might be true about trapezoids?
Trapezoids have two congruent sides, or parallel sides. Parallel.
Parallel only, not congruent.
Parallel. No, yeah, just parallel.
But that doesn't really help either. Well, it kind of does.
Kind of, yeah.
In other words, what does it mean about the relationship between that and this?
That they're supplementary to each other.
Correct. And what does it mean about the relationship between this and this?
That they're, congruent to each other.
Oh, do they look congruent?
Well, it's less than 90, so adjacent to each other.
Okay. Here we have a parallel line. Here we have a parallel line. So
that they're also, supplementary to each other?
Correct.
Okay.
In other words, we're looking at the following. It's a great skill to always be able to translate this problem into two parallel lines with a transversal. Well, here's my two parallel lines. There's the transversal.
Okay.
Okay. Remember what you know about two parallel lines and transversals is there's only two angles there. 1 and 2 are supplementary. And in this case, that's 4 is this one. This one is this one. So 4 and 6 are supplementary also.
Yeah.
So what equation can I write?
So we could say, well, since they're all supplementary, we could do 4x plus 3 plus 11x minus 3 plus 13x plus 5 equals 180.
Just these two parallel lines.
My bad. Yeah.
That gives us an equation we can solve.
Uh-huh.
One variable in that equation. In other
Okay.
words, if you can leave it in one variable, do so, because that means you can solve it immediately.
Okay.
Okay? So the key
Okay.
here was this step here,
Uh-huh.
based on what?
Based on like the supplementary angles.
No, based on adjacent
Or
angles
J's.
of parallel lines theorem.
Okay.
When you have two parallel lines, the theorem says that adjacent angles are supplementary.
Okay.
Well, that angle, these two lines are parallel. You know, we're not even talking trapezoid yet. All
No.
you know is that that line's parallel to that. I can see that's a transversal. That means that plus that equals 180.
Okay. That makes sense.
Means 15x equals 180.
X is equal to 12.
Uh-huh.
Okay.
Okay.
Now
Now,
Y.
let's look at this. We still have our parallel lines in this transversal. So what's the relationship between these two angles?
Like the two, like 13x plus 5 and Y.
Uh-huh.
That they are supplementary to each other.
Right. We know what x is.
Yeah, so
So
we can just plug
13
that in.
times 12 plus
Uh-huh.
5 plus y equals 180.
Yeah, exactly.
And now just solve that.
So 13.
156 plus
Mhm.
5 plus y equals 180. So y is equal to 19.
Yep. That's what I got.
X is 12, y is 19. And
Okay.
notice that in no place did we call upon any theorem regarding trapezoids.
No.
Every theorem we used was based strictly on parallel lines and transversals.
Okay. Cool.
Okay,
Okay.
let's look at number 4.
Uh-huh.
Let me make a little bit more room here.
Okay.
Yeah. All right.
Okay. Let's see.
What
So,
theorem is going to be at play in number 4? First of all, what kind of figure is this?
that's a trapezoid.
Okay, but and we still have parallel lines.
Yeah.
But notice that all of the theorems that regard parallel lines have to do with angles.
Uh-huh. Yeah.
This problem, that's a side length. That's a side length. That's a side length.
Okay.
And you can tell because it's outside the line or on top of it.
Yeah, exactly.
In other words, you can tell that that's a length, not an angle.
Uh-huh.
That these are angles over here.
Mm-hmm.
So the fact that we're dealing with side lengths here probably means we need much more than just parallel lines.
Mm-hmm.
Over here, the only thing we needed was parallel lines. We didn't need to know anything about trapezoids.
Yeah.
Well, here we need trapezoids. We're looking at a trapezoid, the whole figure.
Mm-hmm.
Okay.
Okay.
What is this middle line called?
The mid-segment.
Okay. Why is it a mid-segment?
Because it bisects the two angles, or the two sides into two equal parts.
Good. And what can I say about 7x minus 1?
That it's half of 10x minus 9 and 5x plus 3.
There you go.
Okay.
So give me the equation.
So we could use 7x minus 1 minus, or is equal to 10x minus 9. Or no,
You said it was
90.
equal to half.
Huh? Yeah.
So
So
let's write it exactly as you said it.
okay. Half of 5x plus 3 over
Huh?
10x minus, or just, yeah, plus 10x minus 9.
You see why
Okay.
it's plus?
Yeah.
What this
Uh-huh.
mid-segment is the average base. Remember
Okay.
when I talk about the area of trapezoids, I always like to refer to the average base.
Okay.
It's easier to remember the formula. In other words, if you remember that a rectangle's area is base times height, well,
Uh-huh.
trapezoid is average base times height.
Yeah, exactly.
Okay, well, what's the average base? It's the mid-segment.
Okay.
That's the average base. And how do you get the average base? You add base 1 to base 2 and divide by 2, which is exactly what you did over
Okay, cool.
there. Okay, solve
Okay.
that.
And then so let's see. So it'd be
The first step.
we would well
Get rid of your
we
parentheses, get rid of your
yeah.
denominators. Always those two things. When you're solving algebraic equations, look to get
Okay.
rid of parentheses first and
Uh-huh.
denominators second. Well, I have one set of parentheses and I have a denominator right there.
Mhm.
So let's get rid of the parentheses first. Simplify everything that's inside there.
Okay, so it would be 7x minus 1 is equal to uh 2.5x
Now,
plus 1.
hold on.
Huh?
First of all, we're getting rid of that.
Yeah.
Simplifying that only.
Oh, okay.
All we're doing is getting rid of the parentheses.
Okay, so it'd be
Let's not
2.5x.
change any other thing just because I want to do it step by step.
Okay. So it would be 7x minus 1 is equal to 1/2 times, yeah, times 2.
Combine
Huh?
like terms.
Oh, that's right. Yeah, my bad. So it'd be 15x plus or minus 6, my bad.
So that's
Okay.
2. Now we still have parentheses. You
Uh-huh.
can get rid of the parentheses actually by multiplying everything by 2. Would be the
Okay.
easier way to do it. Notice that if I distribute and multiply a half times this, I'm going to have a decimal
Uh-huh, for sure.
fraction. I don't like fractions.
No.
So let's multiply both sides of the equation by 2. That not only gets rid of our denominator, but it gets rid of the parentheses. Because when we multiply
Okay.
this right side by 2, I no longer need those parentheses.
Okay.
So what's the next line? Multiply both sides by 2 and read the next line to me.
So it'd be 7x minus 1 is equal to
Hold on.
30x.
I'm going to multiply both sides by 2.
Both sides, so it'd be 14x minus 2 is equal to 30x.
No? I'm multiplying this by 2. That 2,
Wait.
I cancel that 2.
So.
That's why I'm multiplying both sides by 2.
Oh, so.
Get rid of the 1/2.
Let's get rid of that. So it'd be 15x minus 6.
Exactly.
Okay. Okay.
And now notice how easy the problem has become.
Uh-huh. Okay, that makes sense. And yeah, 4 is equal to
And I never had to do fractions.
Okay,
And I never had to distribute this 1/2 to this 15 number.
Okay.
And the only reason was I chose to multiply both sides by 2 to get rid of that 1/2.
Uh-huh.
And that got rid of the half and the parentheses.
Okay, cool.
And we solve for x. So
Okay.
now, and that's all we had to do. Okay. Now, this statement right here is based on what?
Based on like a theorem?
Well, I guess the theorem would be the mid-segment
Yeah.
definition for trapezoid or something like that.
Yeah, something that is
Probably a theorem I could find here pretty quick that has to do with the midsection of a trapezoid.
Okay.
Yeah, I know. I was just looking at it, I think.
It's all good.
I don't see it right offhand, but that's what it is, in other words, the definition of midsegment
Okay.
is the average base.
Yeah.
And you get the average base by base 1 plus base 2 divided by 2.
Okay.
And once you define that equation, you don't need any more theorems. In other words, once you've defined that, because the midsegment is equal to the average base, you're done with explaining anything else in terms of theorems.
Okay. Makes sense. Okay.
This one.
Let's see here. So number 5.
Kind of,
So since there are,
what kind of figure is that?
that's an octagon.
Count the sides.
Actually, no, it's only 7 sides.
It's only 6.
No, 6. 6, my bad. Gosh. Should be a hexagon.
Okay. What kind of hexagon?
Like a regular hexagon.
Regular. Regular meaning what?
That all sides are congruent.
And all angles are congruent.
All angles are congruent.
Not just all sides.
Angles, yeah.
But it's all angles. And you can see that they've labeled every angle as being equal to one another.
Uh-huh. Yeah.
Okay. So to solve for x, to solve for one of the angles, I'm asked to solve for the interior angle.
Uh-huh.
What do I have to do?
So would you do just 14x plus 22 times 6?
Equals what?
What equals 180? 360. 360.
What are the sum of the angles equal to in a hexagon?
360, right?
Triangle is 180.
Uh-huh. And then like a
quadrilateral is 360.
Mm-hmm.
A pentagon, or a 5-sided figure, is 540.
540.
There's a general formula. It's n minus 2 times 180.
Yep. Oh, that's right. Yep.
We learned that. So a hexagon has, what's the sum?
So the sum would be 540. Well, no.
What's n?
So you would... Wait.
What is n in a hexagon?
N would be 6.
Okay. What's 6 minus 2 times 180?
180 times 4 is... What is that? 3600? No, 720.
Okay.
Okay.
How
Okay.
many angles are in this hexagon?
6.
So what's each one?
Well, each one would be...
If the total is 720, and there's 6,
so would you just...
6 each ones.
Yeah, 720 divided by 6.
What's that?
Let's see.
You should have.
That would be 120, my bad.
Okay.
Yeah.
All right. I was just going to suggest you have a calculator when we do this,
Yeah.
so you can do those quickly. Although it's actually, I actually prefer you doing it without a calculator. I think it improves your arithmetic skills.
It does. Yeah, I was trying to do it in my head.
Okay. And you did it?
All right.
Okay. So that angle is 120. So how do I solve for x?
So to solve for x, you do 14 times 120 plus 22.
14x plus 22 equals what?
14x plus 22 is equal to 120, my bad.
Okay.
Oh.
14 equals 98. X equals 7.
Okay.
Okay?
Okay.
Okay. Let's look at number 6.
Okay, cool. We're flying through these.
Yeah.
So that's... I appreciate that.
Okay.
Awesome. Okay.
What can I say about number 6? What kind of figure are we looking at?
Triangle.
What kind of triangle?
Yeah.
What,
An isosceles triangle.
okay. So what can I say?
So since only two sides are congruent to each other, so we could do 3x minus...
There's one other thing that's true about isosceles triangles. It's not just two sides are congruent.
Two angles are congruent as well.
Their opposite angles are also congruent.
Okay.
Now,
yeah.
When I say opposite to a side, you know what I mean, right?
Uh-huh.
Okay.
Yeah.
That's the opposite angle to that side.
Yeah, exactly.
This is
and then that's the opposite
angle to that side.
Yeah.
This is the opposite angle to the base.
Okay.
So
gotcha.
if I'm going to say the opposite angles are equal, what can I write?
So if the opposite angles are equal to each other, so we could do first we could do 3x minus 11 is equal to 90. Yeah, is equal to
No, no, no. What did we just say?
45.
No?
No.
We just said that
Well,
this angle is equal to this angle.
oh, it is equal to 54 minus 2x. I thought we were looking at like the sides.
That's all right. That's okay.
Okay.
Now solve that.
So is equal to 54. And then we could add 2x to both sides, so we get 5x minus 11 is equal to 54.
Okay.
Then we would add 11, so it would be 5x is equal to 65, and then x would be equal to 13.
Okay. Now, if x is equal to 13, how am I going to solve for y?
We would just plug in 13 to x.
Okay. Which gives me an angle of 39 minus 11.
Which would be
28.
28, yeah.
Okay, and that's 28 there, right?
Uh-huh.
You have to
Yeah.
plug it in. I know that if that's 28, that's 28.
Uh-huh.
So what's y?
So we would just add those two together, subtract that from 180, right?
Uh-huh.
So 28 plus 28 would be 56.
Okay.
So 180 minus 56 would be 124.
And that's what y is.
Okay.
If we look at that, we can tell it's greater than 90.
Uh-huh.
Although in a problem like this, I'm not sure that you can check your answer by visually looking. Because
Yeah,
this is
I don't
more
think
of an
so.
algebra problem. They don't have to draw it anywhere close to scale.
Uh-huh.
Okay. But yeah, that's the process. As far as the theorem goes, you might have to say the first one would be opposite angles of an isosceles triangle are congruent.
So, okay, so
Therefore,
opposite angles.
the measurement of this angle is equal to the measurement of that angle, definition of congruence. Therefore, 3x minus 11 is equal to 54 minus 2x.
Okay,
And then,
cool.
and then solve it.
Okay, cool.
Then, after you solve for these two angles, then you have to resort to the theorem that the sum of the three angles is 180.
Okay.
So y has to be 180 minus the sum of these two.
Okay, yeah, that makes sense. Okay.
And two more. Are these our only two left?
Yep.
Okay.
Oh, show my pets.
Timing is good. Now, what is this thing called?
That's a kite, isn't it?
Huh? And
Okay.
the easy way to remember a kite is that it looks like a kite. If you had to
exactly.
draw a kite with a big tail on it,
Mm-hmm.
it might look like that. Well, what's unique about this figure? That side's equal to that side, and those two sides are equal.
Okay.
Okay?
Uh-huh.
So it's a kite,
Mm-hmm.
and are they asking about sides or angles or both in this problem?
Okay. So, like, what would be...
What's y plus 4? Is that a side or an angle?
That's a side.
What's 2y minus 7?
CY minus 7 is also a side, so would you set those two equal to each other?
So we can solve for y immediately.
Uh-huh.
So y plus 4 equals 2y minus 7, because definition of a kite.
Uh-huh.
So y equals 11.
Uh-huh.
Notice why I moved that y over to there?
Yeah.
Because I want the sign to remain positive. If I'd have moved the 2y to the left, I'd have negative y.
Okay, that makes sense.
That's the only reason I do it. It
Yeah,
doesn't
that makes
matter
sense.
which side the variable is on. What's more important is that you deal with positive numbers if you have a choice.
Uh-huh.
Okay. So
Okay.
now that I know y, gosh, I
Mm-hmm.
know that side. I know that. I know this.
2y, yep. Mm-hmm.
That's 22 plus 3. That's 25 length.
Uh-huh.
That's 25 because it's the same length as that.
Yep.
And I can solve for what's this one.
Wait,
I know that angle has to be 66 degrees. So this is
how did
a little,
we get...
go ahead.
Oh, yeah, sorry. So how did we get 25? So that's 25.
Hold it.
Then,
Where'd we get 25?
yeah.
Well, we didn't get 25. We got y. We solved for y. Y is all we've solved for so far.
Yeah. Okay.
Solved it by setting that equal to that.
Okay. Never
Okay,
mind.
so
Yeah.
y is 11,
Mm-hmm.
but that gives us a lot of information. We now know that side length, we know this side length, we know this side length, we know this side length, and we know
Uh-huh.
this angle.
Yeah, exactly.
This problem is different because y is a variable that's used in both angles and side lengths.
Okay.
We haven't seen a problem like that before.
No, we haven't.
Different.
Yeah.
What
Mm-hmm.
do we know about kites in terms of angles? Because we don't have any way to solve for x yet.
Okay.
There's
Um,
no other x's in this picture.
no, there isn't. So we could, well, we know that side would be like the side across from 11x plus 25 is the same.
That angle, not that side.
That angle. Gosh, I keep saying side. My bad.
So this
So
angle
we could
right
set those.
here is that same angle, right?
Yeah. So we can set them equal to each other.
Well, let's draw a picture
Okay.
just so you'll see the equation.
Yeah.
This is 90 degrees.
Yeah.
This is
That's,
11x plus 25. This is 11x plus 25.
mm-hmm.
This one is 66 degrees.
Uh-huh.
How can I solve for x?
We could add the like top and bottom angle together, and then set that equal to
Now let's just add
11.
all four angles together and set it equal to how much?
360,
Okay, and there's only one variable in that.
which is x, yeah.
Right, but I mean there's not two variables. You
No.
don't want to use that as a solution if you have two variables because you won't be able to solve it. But if I
Okay.
do this, I've got 22x plus 50, that's this angle plus this angle,
Okay.
plus 90,
Uh-huh.
plus 66 equals 360, the sum of the angles in any quadrilateral, whether it's a kite or not.
Okay.
Okay?
Okay.
Then 22x equals
120.
6,
Where is it?
154,
Yeah, 154.
which makes x equal to 7.
7, yeah.
So x
Okay.
was 7, y
Okay.
was
11.
11, period. What does that mean?
Perimeter, I think is what it means.
Perimeter. Okay.
Yeah.
Well, that's easy enough. Once you had y, the perimeter was just the sum of.
All four angles.
So, not all four angles.
Or four sides.
Okay. What's
Yeah, my bad.
that side equal to?
That side would be 11.
Oh, y plus 4.
So that'd be y plus 4, and then that'd be
What is it?
2y.
Hold it. What's that number? What's y plus 4?
Let's see. 11, well, no.
Y is 11.
Y is 11, so 11 plus 4 is 15, so that'd be 15.
Over here. Okay.
Then
What's
that'd be
this
20.
side here?
That'd be 16.
2y
Or 15,
plus
gosh.
3.
Yeah.
What's 2y plus 3 when y is 11?
Uh, 25.
What's this side over here?
Also 25.
What's the perimeter?
65, 90. So the perimeter would be 90.
All right. I noticed how you added those four numbers together.
50.
You should never end up with a 5 at any point in that process. Either
That'd be 80.
add those two numbers together to get 30, and then these two to get 50, and then add them together. Notice you don't dealing with any 5s at all.
My bad,
or you could add those two together to get 40, but then don't add 15 to 40 to get 65, because then you have to add 65 and 25.
Okay.
In other words, if you can add these in pairs, it makes the math much more accurate.
Okay,
The reason you came up with 90 the first time is because you were adding them one at a time. In other words, you were adding 25 plus 15 plus 15 plus 25, and it's much easier to make a mistake when you do that.
For sure, yeah. Okay.
Okay?
All right, awesome.
And we have time to do this one here.
What time is it? Yeah, 7 o'clock, yeah.
I have time, if
Okay.
you're cool with it. I have an 8:30, but
for sure.
I have
I have time.
couple of minutes. What's that figure called?
That's a rhombus.
Good, because you saw 4 equal sides. What else?
What's that?
What else is it besides a rhombus?
My bad. It's a parallelogram.
Also, it's a rhombus, but all rhombuses are parallelograms. Okay. So, all of the measurements, let's see, these two are side lengths. Now they're equal. It's easy enough to solve for y, but they don't even want us to solve for y.
No.
They want us to solve for x.
Yeah.
What's that angle there supposed to be?
That's like the like the
when you
bisector.
Have two diagonals of a rhombus, what do they make?
Perpendicular bisector.
No, well, that's true. In other words, they are perpendicular to one another. We don't really care if they're bisecting. At the moment.
Okay.
We don't care. All we need to do is say that 6x minus 6 equals what?
Is equal to 90.
Okay. So 6x equals 96. X equals 16. Now, the fact that we did need to solve for x. Okay. And that theorem is the diagonals of a rhombus are perpendicular to one another. Perpendicular means 90 degrees. So, now how do we solve for y?
Let's see. Perpendicular to each other. So I'm just writing that down. And then, did you say how do we find y?
We've got y in 3 things. We've got y in the side length there. We got y in this side length here. And we have a y down here in this angle.
Okay, so can we just plug in 16 to y?
No, that was x.
Was that? No.
What's true about this side length and this side length?
They're congruent to each other.
So, give me an equation.
So it'd be 5y minus 2 is equal to 12y plus 7.
15y minus 2.
Oh, did I say 12y?
No, you said 5y.
Oh, my bad.
So 3y equals 9, y equals 3. And they want angle HEL. That big angle right there.
45 minus 2 is 43. So HE would be 43, which would make EL 43.
Okay. But that doesn't, so we can get the perimeter, right?
Yeah,
the perimeter is 4 times 43. There's 4 equal sides, that's the perimeter. But to solve for this big angle right here, well, we know that that big angle is the same as this big angle down here.
Yeah.
And we know that these angles are the same.
Yeah, exactly.
So the rhombus has opposite equal angles.
Okay.
Yeah. Well, this angle right here, if I can figure out what angle L is, then I'll be able to work backwards to figure out what angle E is.
Okay.
What is half of L? In other words, what is 7y minus 1? We know y is 3.
Yeah.
But what's this tiny angle here equal to?
20 degrees.
Okay. What's the full angle L equal to?
So that'd be 40 degrees.
Okay. So this is 40. That's 40. What's that total?
So 80. So
all four angles have to total.
320.
360.
Did I say 8 times 4?
360. Well, a quadrilateral.
Yeah, my bad.
Sum of an angles of any quadrilateral is 360.
Okay, yeah, my bad.
So this angle plus this angle, E plus P, has to equal 280.
280, yeah.
So
the perimeter, or HEL would be 280.
140.
Or 1, because you divide that by 2.
Right. In other words, E plus P equals 280.
Okay.
And they're equal. Because it's a rhombus.
Yeah, exactly.
So E would be half that.
Okay, awesome. Perfect.
That's a long day.
It's all good.
I got one more, but I got a half-hour break.
Good. Yeah, take that break.
Well, and the funny thing is, it's going to be the same exact material, so it'll be an easy half hour for me.
That's good. Awesome. Well, you've helped me a lot, so I appreciate that.
Good. All right, Dylan. You take it easy, and I'll talk to you next time.
You too. Sounds good.
All right, bye-bye.
All right, bye-bye.